and write some unit tests just to see if we get the simple case to work, and then build in more complicated unit tests and get those to work afterwards. Okay? So what I've done is I've made up, instead of a driver, I've now moved on to making up the start of a test. And so I've got some worker objects that have fairly short social insurance numbers so that we can see them easily. I've just made 3 different social insurance numbers there. And I've also made one that has a social insurance number that's going to be in the same table slot position. And I'm taking advantage of knowing that we made our hash table of size 10. Okay? And we'll have to find a better way of writing unit tests for that later, but this will work for now. Okay, so this is a little specific to that actual table size. Okay, so let's go and add some unit tests to this thing. We'll do the simple test, which is we'll do add find of just a simple item. Okay, so what we'll do is, I guess we need a hash table up here. And we'll initialize the hash table here. And it's table. So that's a new hash table of whatever's. What should that thing say in the brackets? What are the 2 things that we're trying to group together? The key is going to be, what's the thing that's going to give you the magic number? The worker is, so this is real things here, and the thing that you're trying to store in the table is also a worker. So you're trying to pair up a worker who has a key with himself, which is why you get worker there. Okay, so we'll turn around and we'll do table dot add a, and then if we do worker who is table dot find something, and that's going to be that thing, but just looks like, so we'll get rid of that stuff. Okay, so there's our fake guy. Add takes 2 parameters. The first thing is the key that gives you the hash code or the magic code, and the second one is the item to store, which is the same thing. So there's that pairing of worker again. By the way, that points out something interesting about hash tables. I just said that for the collections, you can take, a list and put it into a tree and build a tree or whatever. There's variations on dumping one thing into another thing. One of the exceptions is that hash tables don't play well with others, because hash tables always have to have both a key and a value. Every other thing that you use, like when you put something into a list, you just put one thing into a list. And so they're not easily transportable back and forth. It's still just the APIs. If you look at it, hash table sort of stands out by itself as different from all of the rest. Okay, so, and then I think that who should be exactly A coming back. Okay, and while we're at it, why don't we try to find somebody else? Who equals table dot find last digit A. Oh no, we'll leave that one for later. Let's just do that one. Okay, so we'll run the unit table, we'll run the table test, and it died. Why did it die? Let's just go have a look. So it died in, this is hash table constructor at line number 8. So it died doing new object 10, and the reason it died is because it said you can't cast that thing to a node. This is one of these weird ones. It always worked before when we played this game. We would make it like when we did like our array list equivalent. You could always do this, but nodes are sort of special because they have E-type things in them, and it gets all confused about what an E-type thing might be, or the value, sorry, in this case. So here's a special little trick, courtesy of Java. You don't use new anymore. You use something that's a little different, and I'll just give it to you here. It looks like this instead. And just let me do the import, and then I'll explain it. I think we might have used this once before. There we go. And this will make the compiler happy. So this is the same thing of I want 10 things. The thing that I want is 10 node objects. And notice there's the .class file. And this actually happens at runtime because it's a class file. Array.newInstance can figure out what nodes are actually going to contain in them, in this case workers, and that's enough to make it happy that when you cast it at runtime or go and get the thing at runtime, it knows. Okay, so that's the equivalent of new in a way, making a new array of nodes. It's just got to be that way. Okay, and it'll still give you the thing saying it's not type safe, but we know that already. Okay, so we'll give that thing a try, and we'll run it, and we pass. Okay, so that was add, find, it finds. What about if we search for B, table dot find B, and I'm not even going to use looks like B. What should be the result?
Null.
Null, because they're not in the table. So who should be null in that case? Okay. So this is the, I can find somebody, and this is people who aren't in the table shouldn't be found, to use the double negative. Okay, and run that thing, and we get a null pointer exception. Null pointer exception happens there. Because
there's a node but no parent.
Null, the only way you get a null pointer exception, I keep saying, is if the thing on the left-hand side of the dot has nothing. So node has nothing in it because there was a null in that slot. Okay, so in find, now you know we can actually do the check a little earlier. We'll do it here. If the table at that table position is null, that means there's not even a node there. right? There's nothing chained off the thing. So in that case, we can just return null to say that the thing wasn't found. Okay? So a little bit unexpected, right? I mean, that's the reason for writing unit tests. It's like, oh, okay, I didn't even get to the point of going down the chain of things because there was no chain. So we'll run that thing. And now it works. Okay? One quick little thing, and we'll write the unit test later. What should you do if you try to add and the table slot is already occupied?
You should go to the end of the chain.
Okay, so we've got the situation where we're trying to put something that ends in a 3 in, and there's already something here. Our code right now says, oh, just put the other thing in there.
Overwrite.
Okay, which will overwrite the thing that's already there, which is what we don't want to do. So we want to have 2 people occupy that table position. So if there's already somebody there, then you're going to have to
Traverse to the end.
traverse to the end to add them. But do you care about order? Because the hash table is unordered anyway. Where's the convenient place to put them on a linked list?
Beginning.
Just put them at the beginning of the list instead, because these things are randomly scattered about the table on purpose in no particular order. We know that already. So we can just link this thing in at the beginning. So let's just look down here for a second. There's the place where we replace the table slot. How would you link this thing in at the beginning? You've made your new node that refers to the thing.
You take what's already there and
Take what's already there and put it into the node to link it together. So as soon as we've made the node, and we know it's not null, we'll make the node. Oops, sorry, we're in fine. Let's go back to add here for a second. Yeah, I was looking and going, this doesn't seem quite right. Here's the node. We'll take a node dot next needs to be equal to
yeah.
the table at table slot. I'll have to put it in the right place, I guess. Eh?
Yeah. Have an equal to it.
We'll cut that out of here. Come on. Doesn't want to do Control X. Okay, we'll do it the hard way. So in here, a node dot next equals whatever's in table sub table slot. Okay, so that says remember that thing, and then what would you do next to get it hooked in?
You just do what you would normally do.
Table sub table slot hooks to that thing. Oh, the code's already there.
What if there isn't a node already there? Or is the array automatically propagating? Yeah, because it's not.
If there's nothing there, you're still gonna a node dot next gets the null,
No, okay.
and then the null is fine. Okay, which is sort of cool. It's like you add one line and you automatically, whether or not there's anything there or not there, you don't have to check. I'm not necessarily a big fan of doing things that sort of magically work and that you have to overlook. So I might have actually written, if it's empty, link it in, where, you know, put it into the table slot and return. Otherwise, if it's not empty, do that, just to make it more clear, because that's not at all obvious unless you played with a lot of linked list code, but I thought I'd show it to you anyway. Okay? So that will now take care of chaining things in. So now what are we going to have to do with find for Monday?
You're gonna have, if you find something in that slot,
Our find code right now says regardless return the first one, but the first one might not be the correct one, So we're gonna have to, if we go through and find something in the slot and it's not null, we're gonna have to go through, check each one of these to see whether or not it matches what?
Key.
The original key number. Okay, so we're gonna have to go back and check against the original key to find a match. So we'll do that on Monday and add some more code to this thing to get that to work. The other thing that we'll do is we'll add code to deal with duplicates. Okay?